Hello, this is Dr. Oz. Today, I would like to show you how to solve a minimization problem, linear programming. So let's start with the given information. Last video, I talked about the model that we have, minimization problem. And now I would like to solve this problem that we talked about in last class. Let me just show you the problem again so that you guys remember. So this was the model for chemical manufacture. All right, so let's translate this into Excel. I would like to start with the given information. My first column, right? So let's start with given information. These are the parameters that are given to me. First of all, we know the processing time. Number of hours per gallon of production. All right. And also we do know production cost. Again, these are dollars per gallon. We do know minimum total production requirement. We do know minimum product A requirement. All right. So now I can write this information or given data for product A and product B. Okay, so we know that product A will require 2 hours per gallon, and product B will require 1 hour per gallon. Product A will cost me $2 per gallon. Product B will cost me $3 per gallon. So these are dollars. And also I know that I'm required to produce at least 350 gallons of total production next month. And also I need to have at least 125 gallons of product A production. In addition, we know time available. For processing time, I have 600 hours available for me. Let's build our model here, create a model section. And optimization models, as I told you, most cases have 3 components. One, objective. In this case, I have only cost information, so my objective is minimize the total cost. 2, my decision variables. In this case, my decision variables is to decide gallons produced for each type of product. I have product A and I have product B. So these are decision variables. I would like to color them yellow. Again, it's a personal preference. And I like to color my objective with green. I choose green, yellow, and red for constraints because of, I guess, traffic lights. But you can choose whatever color you want. So now, since I define my decision variables, I can write my objective function in terms of my decision variables. All right, so my objective function is minimize total cost. So every product A will cost me $2, so times gallons produced A plus $3 times gallon produced B. Again, coefficient times variable plus coefficient times variable. And one thing is important to point out is that we have no idea about these decision variables values now, but we will use Excel solver to solve those values. Finally, let's talk about our constraints. As we discussed earlier, constraints have three components: left-hand side values, which are calculated by us, and relationships to right-hand side values, which should be given to us. All right, so let's enter our constraints here. The first constraint here is the product A, or I can call these two, minimum total production, minimum production A. I will Control C, Control V. I have two constraints here. And also I have Control C, Control V, time available constraint. Finally, I have non-negativity constraint, that my decision variables cannot be negative. All right, so let's start with the first constraint. I like to start with right-hand side because they are given to me, it's easy. So total production is 350 gallons. And I need to produce at least that much. That means the greater than or equal to. And my left-hand side value is, again, coefficient times variable. Since this is linear programming, what's the coefficient? In this case, every A produced will cost me, sorry, this is not the cost, this is number of production. So every time I produce A, basically it will create one product. So I could just say 1 times this, or 1 times the variable is the variable itself, so I don't need to type that. So this is total production for A plus total production for B. When I add these up, I want to have at least 350 products. So currently I produce nothing. And let's go with the minimum A requirement. The right-hand side value is given as 125 gallons. That's the minimum production that I need to have. So that's why it's greater than or equal to constraint, similar to the first constraint. And left-hand side this time is only product A decision variable, because when I produce B, this is not going to help me the production of A. Time available is a constraint that is shared by both products. So right-hand side value is given to me as 600 hours. And the relationship this time is less than or equal to, because I can use up to 600 hours. My left-hand side value is coefficient time variables. And my coefficient is every A produced will cost me 2 hours times A production in gallons, plus make sure the units match. So decision variables are gallons, and has to be, these coefficients should be gallons. Objective is here per number of gallons produced times dollar per gallon. So as you see, this is not, if this is liter, this has to be liter. If this is gallons, this has to be gallon per gallon. All right, so the units have to match. All right, so 1 times the decision variable. So I'm done with the setup here, and now I can translate this into Excel solver. Again, I like to color code them as red because these are my constraints. All right, so let's click on this green cell. So let's go to data solver. If you don't have solver, what you need to do is click on file, then you need to click on options, and then you're going to click on add-ins, and then click on analysis toolpack, and then click on go, and then make sure that your solver is checked, and then click OK. Now you should, it may take a few seconds, and then click on solver now. Now first thing is the objective function. G3, since I click on the green cell, it's automatically selected. Otherwise, I could just click on this icon and click on the green cell, enter. And this is a minimization problem, click min. And decision variables here are the yellow cells. So again, click on the icon, highlight the decision variables, enter. And now I can add my constraints, click add. And I have 2 constraints that have same relationship, so I don't need to add them one by one. These left-hand side values have to be greater than or equal to their corresponding right-hand side values, which are here. I highlighted them. Click add. I have one more constraint, which is time available. Left-hand side value is here. And then this value has to be less than or equal to the right-hand side value is 600. Now, since this is my last constraint, I click OK. As you see here, I have two sets of constraints, including three constraints. And also, I want to make sure that my constraint decision variable are non-negative. So production A and production B has to be greater than 0. This is a linear program, so I will use simplex approach algorithm that we covered. And I can click solve. And once you click on solve, all constraints and optimality conditions are satisfied, perfect, and click sensitivity analysis to create a report, click OK. And as you see here, the minimum cost that I will incur here is $800 by producing 250 gallons of A and 100 gallons of B. And let's see whether this is a feasible solution. All right. So the first constraint, I produce 350, which is greater than or equal to minimum requirement. I produce 250 gallons of A, which is greater than the requirement. I use all my time available for me, 600, which is less than or equal to 600. So this is a feasible solution. Specifically, this is the optimal solution or the best solution for this model. That's it for today, and enjoy business analytics.